Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Sabrinda binti Kamarudin and my matric number is 2210911129. I'm going to present about our topic is power quality improvement using hybrid solar and wind generation for EV charging system. Next is I'm going to introduce our team. We have Nur Alia Shakira Samtul ID, Nur Iwanina Zafira Khairul Rizwan, and Nur Izzati Nurizan. Next is introduction. Electrical vehicles (EV) are growing in popularity, but their charging infrastructure faces challenges like poor power quality. Electrical vehicles (EVs) are growing in popularity, but their charging infrastructure faces challenges like poor power quality, voltage fluctuations, and reliance on fossil fuels. Renewable energy sources like solar and wind are promising but inconsistent, making stand-alone systems unreliable. A hybrid solar and wind energy system combines their strengths to ensure a stable energy supply. Advanced techniques like maximum power point tracking (MPPT) and grid integration further enhance reliability and efficiency. Simulation in PSIM software demonstrate superior power system stability and uninterrupted DC bus voltage performance. This project aims to improve power quality and efficiency while providing a sustainable This project aims to improve power quality and efficiency while providing a sustainable energy solution for EV charging. Problem statement. These problems highlight the need for a hybrid. Problem statement. These problems highlight the need for a hybrid solar and wind energy system with advanced control strategies to address power quality, reliability, and efficiency issues in EV charging infrastructure. First is inadequate charging infrastructure. Limited EV charging stations in remote areas due to insufficient grid connectivity and reliance on non-renewable energy sources. Second is energy supply challenges. Variation in solar irradiance and wind speed lead to unreliable energy production, impacting the availability of consistent power for EV charging. Third is power quality issues. Integration of renewable energy sources into EV charging stations causes instability in the power grid, including voltage fluctuations and harmonic distortion. Last one is resources utilization problems. Lack of hybrid system that effectively utilize solar and wind energy leads to inefficiency and wasted renewable energy potential. Next is objective. The objective of this study are to design and evaluate a hybrid solar and wind energy system that ensures high power quality and energy efficiency for EV charging station. First is hybrid energy system implementation. First is hybrid energy system implementation. We design and develop a hybrid solar and wind energy generation system tailored for EV charging stations in remote and urban areas. Second is power quality enhancement. Utilize advanced control strategies and MPPT techniques to ensure steady power output, minimizing fluctuations in energy delivery. Third is energy efficiency. We maximize renewable energy utilization to reduce dependency on conventional grid electricity, focusing on economic and environmental benefits. Last one is sustainability goals. Reduce dependency on conventional energy sources, promoting renewable energy as a sustainable and reliable alternative for EV charging. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Iwanina Zafira binti Khairul. I will present the methodology for this project. The methodology involves several steps. The first step is to select solar and wind energy as the renewable energy sources for the hybrid system. Solar energy is widely available during the daytime. In contrast, wind energy is more efficient because this energy can generate electricity even during the night or when sunlight is insufficient. By combining these two sources, the hybrid system ensures a more reliable and consistent energy supply. Then, calculation were performed to determine the appropriate capacity for PV panels, wind turbines, and energy storage devices like batteries. Then, the system's design stage involved integrating PV panels and wind turbines into a single hybrid setup. PV panels were included to convert sunlight into electrical energy, while wind turbines were designed to utilize wind energy. Once the design was complete, the system was simulated using PSIM software. In this simulation, the PV panels and wind turbines were connected to an inverter, which converts the generated energy into usable electricity. The simulation also included load components to represent the energy consumption. Then the final step was to analyze the simulation results to evaluate the performance of the hybrid system, which include the total output power, system efficiency, and energy reliability. And additionally, the public and environmental impacts of the system were considered. By reducing usage of fuels, the hybrid system contributes to lowering greenhouse gas emission and promoting sustainable energy practice. Okay, next is the block diagram. The block diagram illustrates a hybrid renewable energy system combining solar and wind energy for electricity generation and distribution. Solar panels generate DC power regulated by a DC-DC converter, while wind turbines produce AC power converted to DC through the AC-DC converter. Both energy sources are integrated into a single DC bus, and the combined output is converted to AC power by using the DC-AC inverter for distribution to the loads or to the power grid. This system ensures reliable and efficient energy supply by utilizing both solar and wind resources.
Assalamualaikum. My name is Nurizati binti Norizan. I will be presented to you about our project result. This is our PC model of integrated for wind and solar PV for electrical vehicle charging station. The PSIM simulation model illustrates the integration of wind and solar photovoltaic system for EV charging station. The design efficiently combines both renewables energy sources to ensure a consistent energy supply, overcoming intermittency issues. The wind turbine generates power using an AC synchronous generator, and the PV system supplies energy through its photovoltaic cells. These sources are connected via rectifier and inverter stages to provide stable DC power to charge EV batteries. The combination ensures optimal energy output under varying weather conditions. As we can see here, on the left side is the performance of the PV cells was evaluated using current voltage and power voltage characteristic curve. The effect of irradiance on current voltage curve. As irradiance increase, the current output rises significantly, leading to a proportional increase in power output. Meanwhile, the effect of temperature on power voltage curve, while the irradiance enhance power generation, increased temperature slightly reduces the voltage output of the photovoltaic cells. This results in a shift in the PV curve toward lower power levels at higher temperature, emphasizing the need for temperature control mechanism in PV system to maintain efficiency. Apart from that, on the right side is the wind turbine generator output voltage. The wind turbine generator provides a consistent power output complementing the solar PV system. This hybrid configuration ensures a steady energy supply to the charging station even during periods of low solar irradiance or wind speed. As we can see here, on the above is the output of AC synchronous generator at 2.5 millis per second wind speed. The wind turbine performance was assessed at a wind speed of 2.5 millisecond. The AC synchronous generator effectively converted wind energy into electrical power, then producing a steady output suitable for rectification and integration with the PV system. This demonstrates the system ability to utilize wind energy even at a low wind speed. And for the output of maximum voltage PV cell shown below, the maximum voltage output of the PV cell was evaluated under optimal irradiance conditions. The result shows that the PV system can achieve high efficiency, contributing significantly to the overall energy supply of the hybrid system. The results validate the performance and reliability of the hybrid solar or wind energy generation system for EV charging. By combining both renewable sources, the system achieves improved power quality, consistent energy supply, and reduced environmental impact, aligning with the study's objective. As we can see above, is the output of rectifier stage. The rectifier stage converts the AC output from the wind turbine and PV systems into DC power. The rectified output voltage is stable and ready for further processing in the inverter stage. This stage plays a critical role in ensuring compatibility between the hybrid energy source and the EV charging system. Meanwhile, below shows output voltage of inverter stage. The inverter stage transforms the DC powers into AC powers required for EV chargers. The output voltage from the inverter is well regulated and ensures minimal distortion, meeting the power quality standards necessary for EV battery charging. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Nur Alia Shakira binti Samsul ID and my number matrix is 2210911115. Today, I will present the societal and environmental impact of a hybrid solar and wind energy system for EV charging station. Let's start with the societal impact. This hybrid system promotes the adoption of EV, advancing clean transportation by providing renewable power EV charging station. It encouraged the use of EV, which are essential for reducing urban air pollution. It also ensures a reliable energy supply, particularly in areas with limited grid access, helping both urban and rural communities. On an economic level, the system fosters job creation in the renewable energy sector, from solar panel installation to wind turbine maintenance. Now, on the environment impact. The system significantly reduced greenhouse gas emission, preventing 612 tons of CO2 annually by replacing fossil fuel-generated electricity. This is equivalent to removing over 70 traditional cars from the road. It utilizes clean and renewable energy sources like solar and wind, which drastically lower pollution compared to conventional energy. Lastly, the system is highly efficient. The rectifier and inverter stage achieve 90% and 95% and 90% efficiency, minimizing energy losses during operation. For technical highlight, the wind turbine delivers 1,532.58 kW at wind speed of 3 milli per second, contributing 50% of the energy demand. Similarly, solar panels supply 330.037 watt per panel, meeting the other 50%. Together, they balance intermittency and ensure consistent power delivery. This figure validates the hybrid system's ability to support clean urban mobility by enabling EV charging with renewable energy while reducing its ecological footprint. By using wind and solar, this system eliminates this pollution and greenhouse gas associated with fossil fuel. Finally, let's conclude with the key outcome of this project. The objective was to develop and access a hybrid solar and wind energy system for EV charging. The goal was to ensure consistent power quality and maximize energy efficiency. Here that was achieved. The system maintained a stable DC bus voltage of 400 volt, ensuring consistent power output. The energy generation was balanced, with one turbine and solar panel each contributing 160,000 kilowatt-hour per year, meeting an annual demand of 720 kilowatt-hour. Energy losses were minimized with high conversion efficiencies, which is 59% efficiency in rectifier and 90% efficiencies in inverter. From an environmental perspective, the system prevents 612 tons of CO2 emission annually, showcasing its potential to combat climate change. It also promotes renewable energy adoption, providing a sustainable and environmentally friendly solution for EV infrastructure. To conclude, this hybrid solar and wind energy system not only deliver consistent power quality and efficiency, but also support the global shift toward renewable energy and sustainable transportation. It validates the possibility of revolutioning EV charging infrastructure while minimizing environment impact. So that's all from me. Thank you.